Welcome, data professionals. Today, we are diving into a transformative Cortex AI feature, AI Parse Document. I will show you how to seamlessly extract deep, structural value from unstructured files like PDFs right inside your Snowflake data cloud. Let's start with the what. AI Parse Document, which is the updated and more powerful version of the original Parse Document function, is a fully managed Cortex AI SQL function. Its primary job is to look at unstructured files like a dense 50-page PDF, a PowerPoint deck, or a scanned JPEG and extract not just the raw text, but the structural layout. It reads your documents directly from a Snowflake internal or external stage. The only strict requirement here is that your stage must be configured with server-side encryption, or Snowflake SSE. By calling this single function, you instantly convert locked-away document data into a rich, structured JSON payload containing Markdown, ready for downstream analytics. Look at the data flow on your screen. On the left, you have your unstructured files entering the ecosystem. They are placed into a Snowflake stage secured with Snowflake SSE. The AI Parse Document function acts as the extraction engine in the middle, reaching into that stage, analyzing the files, and outputting rich text, layout markers, and structured JSON or Markdown on the right. It completely eliminates the need for complex external OCR pipelines. So, why do we use this? Why not just use a standard Python text reader? The biggest driver is RAG pipeline optimization. When you feed a generic text dump of a PDF into a large language model, it loses the table structures and paragraph context, leading to poor answers. AI Parse Document extracts the data with high fidelity, maintaining table rows and reading order. This makes your AI chatbots incredibly smart. It allows you to build massive, semantic knowledge bases from historical contracts, reports, and emails. Furthermore, it boasts robust multilingual support, processing 12 languages natively. And because it runs on Snowflake Compute, it is horizontally scalable. You can batch process millions of pages automatically without moving your data to an external service. This block diagram illustrates the strategic value pillars. At the top, AI Parse Document branches into three main capabilities: RAG optimization, which fuels intelligent chatbots, automated workflows, enabling massive batch analytics through Snowflake tasks, and multilingual processing, giving your data global reach. This single function unlocks multiple enterprise-level AI capabilities. Let's deep dive into how specifically the two processing modes. When you invoke this function, you must choose between layout mode and OCR mode. Layout mode is your powerhouse. It uses advanced visual language models to understand the document's structure. If there is a table in your PDF, it outputs that table perfectly formatted in Markdown. It understands headers and logical reading order, even in multi-column research papers. OCR mode, on the other hand, is a faster, text-only extraction method. It strips away formatting and just gives you the raw characters. You control this by passing a simple JSON configuration object in your SQL call. As a rule of thumb, use layout mode when structure matters, like with SEC 10K filings or complex contracts. Use OCR for flat text, screenshots, or simple scanned receipts. This decision tree is the mental model you should use as a developer. You ask one question: does document structure matter for my downstream application? If yes, follow the top path to layout mode, which generates rich Markdown and tables. If no, follow the bottom path to OCR mode, yielding a simple, flat raw text string. It is a straightforward architectural choice. Now, let's look at the actual SQL execution. To parse a document, you write a standard select statement calling AI Parse Document. The first argument isn't just a string path. You must use the TOFile helper function. You pass the stage name and the relative file name into TOFile, which securely points the AI engine to the document. The second argument is your configuration JSON object, where you define your mode. Administratively, there's a strict security requirement here. To execute this function, the user or service account running the query must be granted the Snowflake.Cortex user database role. Without this role, the query will fail. This ensures that only authorized workloads can consume Cortex AI compute credits. Follow the chronological flow in this sequence diagram. The developer submits the SQL query using the TOFile helper. The Snowflake SQL engine passes this to Cortex, which first performs a strict security check for the Cortex user role. Once validated, Cortex fetches the file from the encrypted stage, extracts the layout, and returns a comprehensive JSON object back through the database to the developer's screen. The entire complex AI inference is abstracted into a single SQL command. As you move into production, you will encounter massive documents. You don't always need to parse all 200 pages. This brings us to advanced navigation. You can pass the page split option set to true to force the JSON output to separate the text page by page, rather than returning one gigantic string. Even better is the page filter option. Let's say you only need the executive summary on the first page. You pass an array stating start, 0, and 1. Remember, Snowflake uses zero-based, exclusive end indexing here. So 0 to 1 means just the first page. Why is this critical? Because Cortex AI bills you per page processed. Using page filter on a 500-page document to only read the first 5 pages will drastically reduce your compute costs and latency. This flow diagram visualizes cost efficiency. We start with a massive 500-page PDF on the left. We apply our page filter configuration, requesting start 0 and end 5. The engine surgically extracts just pages 0 through 4, bypassing the rest entirely. As shown on the bottom branch, pages 5 through 499 are ignored. You are billed only for the 5 pages processed, resulting in a highly optimized, cost-effective pipeline. Let's get into the deep technical constraints, because architecture requires knowing the limits. AI parse document has hard ceilings. A single file cannot exceed 100 megabytes, nor can it contain more than 500 pages. Furthermore, the visual resolution of any single page cannot exceed 10,000 by 10,000 pixels. If you hit these, the function will throw an error. For billing, you are charged a specific credit amount per page for PDFs and images. For plain text or HTML files, Snowflake calculates cost by dividing the file into 3,000-character chunks, billing each chunk as a page. A critical best practice here: do not use an extra-large warehouse hoping the AI function runs faster. The AI models run on dedicated backend compute. Use a smaller warehouse, like XSmall or Medium, just to orchestrate the SQL queries, saving you massive warehouse costs. Here we see the validation and billing lifecycle. The input document hits the constraint check node first. If it violates the 100 megabyte size limit or the 500 page limit, it routes to error states. If it passes, it moves to the Cortex backend processing. Notice how this is decoupled from your warehouse. It calculates your cost per page and then routes the final payload back through your XSmall warehouse. This architecture keeps your local compute footprint incredibly light. Let's apply this to a real-world scenario. A financial firm wants a chatbot to query SEC 10K filings. These are massive PDFs filled with dense financial tables. If you just read the raw text, the tables turn into a jumbled mess. Instead, we use a 4-step architecture. Step 1, we ingest the PDFs using AI parse document in layout mode, transforming those complex tables into clean markdown. Step 2, we break that markdown into chunks and generate vector embeddings using the AI embed function. Step 3, we load these chunks into a Cortex Search service, which indexes them for hybrid semantic search. Step 4, we build a Streamlit app. When a user asks, "What was Q3 revenue?" the app searches the chunks, finds the exact markdown table, and passes it to AI Complete. The LLM reads the perfectly formatted table and gives a flawless, hallucination-free answer. This diagram showcases the complete enterprise RAG pipeline. We start with the 10K PDF files on the left. The crucial first step is AI parse document converting them into markdown and tables. Without this, the pipeline fails. Those clean tables are embedded and pushed into the Cortex Search index in the middle. When the user interacts with the Streamlit chatbot, it pulls from that precise index, allowing AI Complete to generate a perfectly accurate financial answer on the far right. To wrap up, remember that AI parse document isn't just an endpoint, it is the foundational first step of a composable AI pipeline. Once you parse the document, you can pipe that output directly into other Snowflake AI functions. You can feed the text to AI Classify to automatically categorize files as invoices or contracts. You can pass it to AI Extract to programmatically pull out vendor names and invoice totals into strict JSON schemas. By wrapping these SQL commands inside Snowflake streams and tasks, you can build an event-driven architecture that automatically processes every new document dropped into your cloud storage buckets. Thank you for joining this training session. To master these AI architectures and advance your career, please like this video, subscribe to the channel, and visit quicktechie.com for premium certification prep, featuring extensive Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Happy building! Our final sequence diagram illustrates a fully automated event-driven architecture. A new PDF arrives in the external stage, triggering a Snowflake stream. The pipeline automatically calls AI parse document to grab the text. That output immediately flows into AI classify and AI extract, which identify the document type and pull out specific entities. Finally, that structured data is inserted directly into your Snowflake tables for business reporting. This represents the pinnacle of modern data engineering.